In this video clip, we're going to go on to learn about proportions and how these differ in a very important way from ratios, which we covered in the previous video. In the previous video, we learnt about ratios, and we also learnt that the ratios are very important building blocks for an effect measure known as an odds ratio, which you're going to learn about later. Now, proportions are also very important building blocks, but for a different kind of effect measure. And you'll see later in this course that we call that effect measure the relative risk or the risk ratio or the relative proportion and so on. So these again are very important epidemiological concepts. The proportion differs from the ratio in the sense that the denominator includes both the numerator and the denominator. So it'll be x over y plus x, whereas the ratio would have been x over y. The proportion is now x over y plus x. So x, the numerator, is also included in the denominator. Proportions are often converted to percentages by multiplying by 100. As a matter of detail, we shouldn't refer to proportions as a percentage, but you may express them as a percentage if you so wish. It's a true fraction, of course, unlike the pseudo fraction that we had with ratios. This is a true fraction because the numerator is also present in the denominator. Just as another point, proportions must fall between 0 and 1. They cannot be negative and they cannot be greater than 1. If you're expressing them as percentages, they must fall between 0% and 100%. As an introductory example, let's turn back to our basket of mangoes and oranges. Remember, the ratio of mangoes to oranges was 20 to 80. We now want to know what proportion of the pieces of fruit in the basket are mangoes. It's not 20 over 80, it's 20 over 20 plus 80. So it will be 20%. So I've worked through that little sum for you here. Make sure that you understand the distinction between a proportion, which includes the numerator both on top and bottom, and a ratio where the numerator is only present on the top. This is the first of two slides where we illustrate the concept of proportion in an applied way for epidemiology. In this first one, we talk about a ratio of those who died who lived to those who lived. So if we had a total of 123 people, 44 died, 79 lived, what proportion died? It'll be 44 over 44 plus 79, because we must include the 44 in the numerator and also in the denominator. But we must also include those who lived in the denominator. So that comes to 0.36 or 36% of the people who died. So the proportion is 0.36, the percentage is 36. Another example, if 1.79 million births were male and 1.79 million were female, then the proportion of births that were male is 1,791,000 over, and then at the bottom you must add together the males and the females. And so that comes to 0.531, or if you want it as a percentage, 53%. The proportion is 0.531. The percentage is 53%. I hope that's clear. On this final slide, we illustrate two other applications where we use proportions. We use proportions to estimate risks, and also we use proportions for prevalences. These are both important epidemiological concepts, as you will see as the course progresses. Let's look at risks first. Let's assume that there were 200 people who are disease-free at the beginning of a study, and over the winter, 80 of these 200 people developed a cold. and 120 therefore did not. The 20 plus 120, the 80 plus 120 must add up to 200. So the risk of developing a cold was therefore 80 over 80 plus 120, which equals 80 over 200, which comes to 0.4. You could express this as a percentage as well, but if you're talking about the prevalence, the risk is 0.4 and the percentage is 40%. The next one is the prevalence. So you might say that out of 200 patients with COVID-19 disease, 20 had recognized risk factors for severe disease, which means, of course, by implication, 180 did not have the risk factors. So the prevalence of risk factors was 20 over 20 plus 180. You see the 20 appears again on both the top and in the denominator on the bottom. So that comes to 0.1, or you could express it as 10% if you prefer.